Audio Jungle. Audio Jungle.
All right. Like last class, we had seen that minimum drag condition and what was the thrust required condition that you already have seen that derivation and all. Now in this class, we'll talk about the power system. Okay, and in the power also we have two types of power: power available and power required. Okay, so let me write here power. So basically, if you say power, so two types of the power we have here, which is nothing but power available power required. Okay, you can say this is nothing but internal and this is what external. Okay, depends on engine specification. This one is what depends on drag only. Okay, fine. So this power available is nothing but basically PA represented by PA, and this power required it is represented by PR. Okay, now first we'll talk about the power available. So how many types of power system we have? Two types, right? So we'll talk about power available. Power available. Okay, now in the power available we'll talk about power system first, and for that power system we have to talk about the power available. Two type of power system we have. It is nothing but reciprocating engine, which is basically propeller engine. Next one is jet engine. Okay, like turbojet, turbofan, all. Okay, now so for the reciprocating engine, okay, and jet engine, we have to check what is the power available. All right, now so reciprocating engine, in the sense you are talking about the propeller combination. Okay, the propeller combination. So you can check, it is nothing but okay, this is the propeller combination, and this is nothing but jet engine. Okay, compressor, combustion chamber, We'll talk about turbine, combustion chamber and turbine. So this is what jet engine. This is what the propeller driven engine or reciprocating engine propeller combination. Alright. Now for both jet engine as well as reciprocating engine, we have to check the power available and power required. So if you go for the reciprocating engine, okay, propeller combination, and this is what jet engine. So let me draw the plot here. Why this plot variation is like this? The secondary discussion, secondary in the sense that is the part of jet propulsion. So when I will teach jet propulsion, then I will explain this graph also, why this graph is like this and all. Okay. Now here I just want to show you like why for jet engine we are considering thrust as a constant parameter, and why power we are considering as a constant parameter for reciprocating engine. Okay, so first I will draw, it is power available, is power available here, and this is power available, and this one is nothing but velocity or free stream mag number. It's your choice what you want to write. Availability. So if you draw this plot, so how you looks like, this will be like, this is the, after this will be constant. So this is nothing but power available for what, for reciprocating engine, and for the jet engine power available, this graph will continuously increasing, which indicates it is approximate constant and it does not constant. So for jet engine power available will not be a constant, but for reciprocating engine power available will be constant. But for the same reciprocating engine, propeller driven, and this is what jet engine. If you again draw the plot, which is nothing but thrust available versus velocity, I can say, as I told you, this analysis will come again in propulsion chapter subject, jet propulsion basically. So there I will explain this graph. Okay, don't bother about it, it's very simple one. Here I am not going to explain the reason why this plot is not varying like this, otherwise it will take so much time. So but in jet propulsion I definitely I will explain it. Here I just want to tell you why in jet engine we are taking thrust as a constant parameter. So for reciprocating engine thrust variation will be like, okay, somewhere for propeller when this velocity is what approximate to subsonic, you can say. So once you can say m infinity becomes 1, so thrust you may lost because of the shock formation for in a propeller. Okay, so in propeller shock formation will be there, so because of it it will drastically loss of the thrust. Okay, now but in case of jet engine this will be like almost constant. Okay, so in fact for the jet engine, that's the reason you are able to fly with supersonic speed. Turbojet engine you are using for the supersonic jet aircraft. Why? Because if it is going for more than Mach 1 also, it is going to give good performance. I mean thrust you may get good. Okay, but in case of the reciprocating engine, you may lose the thrust. So here thrust available will not be constant. Here thrust available approximate constant. Hope now it is very clear. Now conclusion. What you concluded here? We can say conclusion is what? Point 1. For jet engine, thrust available which is approximate constant to be considered as performance parameter I had in the sense for further calculation, further analysis and all. For reciprocating engine or propeller driven engine, power available is what? Almost constant to be considered as performance parameter ahead. Hope you understood now. Okay, check. Now it's in front of you. Like and thrust. We'll write here thrust also. Uh, Third point is not required at all because one thrust available I have taken and power I have taken. So from full diagram, two are very important. What are two? Where what is the constant parameters? Thrust is constant for jet engine. So I have taken this as a performance parameters for further calculation. And if you check power available, so here this power available is what? Constant in propeller driven engine. So power available I am considering as a performance parameter for reciprocating engine or propeller driven engine. Alright. Now this one is clear. So no need to write third point. It's a common one. Now, so this is all about power available. Hope you understood. So now if I say power available, then you need to say like, okay, we are going to talk about the propeller driven engine. Okay. If I'm saying thrust, then it means it is jet engine. If I'm saying watt, like 200 kilowatt power generated by the aircraft, so means you are talking about the that propeller driven engine or piston prop engine. Okay, or reciprocating engine based aircraft. All right. Now, so here this power available concept is what clear. Now we'll talk about the power required. Okay. Fine. So power required. Power required. Why there is the power? It's because of drag. The tree only I explained here in starting. See, so that power required is what basically because of drag, right? So what is the power required? Check. If you say power required or only now power if you say, then automatically it will be considered a power required. So what is the power required? It is nothing but drag into velocity. Yes or no? Drag into velocity. Yes, this one is clear to all. Now we have to check this manipulation. It's a simple only. It's not tough. It's very simple. So as we know that drag we can write separately here. Drag is nothing but the, for steady level flight, we can say drag into L by L we can write, and for steady level flight what is the lift? Lift is nothing but weight also, weight right. So what is the power required? Power required is nothing but drag into velocity, which is nothing but uh, drag into weight of the aircraft by lift of the aircraft into velocity. Yes or no? Now very simple. What we can write here? Check. A little bit I am going fast because it's a simple mathematics only. Even though we will not derive the expression, not important. The important is the final result. But here I am explaining the steps also. So that's the reason I am going fast, little bit fast. Okay. Now check. What we have here? Drag, weight of the aircraft, lift of the aircraft into velocity of the aircraft. So what we can write? We can write weight here, weight of the aircraft, drag by lift of the aircraft into velocity. Okay. Now we know this drag by L. You can write CD by L. We know for constant altitude. This is for constant altitude. D by L is equal to CD by L. Okay. And what is the velocity? Velocity, you know, it is nothing but 2W divided by rho S dm. Yes or no? How you will get this? Actually it came from lift is equal to weight is equal to half rho v square s into cl. So from here velocity you can get this. Now what is the power required? Check. Weight cd by l is nothing but cd by cl. Velocity is nothing but 2w divided by rho s c. I hope this one is clear to all of you. Yes or no? All right. Now, so we can write this value. So what will get? PR is equal to, is nothing but W 2W rho SCL. Yes or no? Now you can take this W outside. So W 1 by 2. 1 W we have. So what this value will be? What will be this value? You can do one thing. You can take this W inside or take this outside. It's your choice. So because all the constant I just want to keep in one box, so I can write here. Take this W inside. So it will be 2 W, it will, if it will go inside, it will be W square. So W square into W, it will be W cube divided by rho S. Okay, fine. And CL will also be here, but I am taking CD. CL is nothing but root 1 by 2, root of CL. It is the root of CL, right? In denominator. So you can take CL outside, so it will be CL 1 by 2. We have CL 1, so 1 plus 1 by 2, it is CL power 3 by 2. Hope you understood. This is simple mathematics here. Okay, this is simple mathematics, nothing else. All right. Now, so we all know why I am doing this, because I just want to write drag polar. What is the drag polar? It is nothing but CD plus ACL square. Keep this value in above equation. So what we make it? CD is nothing but CD naught ACL square divided by Cl to power 3 by 2. Alright. Now, so check this term is what constant. This term is what basically constant. Let me write one more step. So what I have written here. CD naught in denominator it is Cl to power 3 by 2. This is the required power. Okay. This is what required power. If they will ask what is the required power and all the value they have given to you like K and all. So this is the one way to calculate. But now we want to write minimum required power. Now condition is what came. What is the condition now? They are asking PR minimum. Okay. They are asking PR minimum. So how to minimize this? Very simple. To minimize the function, what you will do to minimize the function? This is the basic mathematics. To minimize the function, you just take first derivative and make it equal to 0. To maximize the function or to minimize the function, concept will be same only. Yes or no? Check this first term. This is what constant. This is what constant. Okay. What is the variable? We have variable is what this bracket CD naught KCL square divided by CL for 3 by 2. You just take the derivative of it. Okay. Take the derivative of it with respect to what? With respect to CL. Why? Because it is varying with the CL only. Because rest quantities are constant, like CD naught is constant, K is constant, only variable is CL. So with the variable I am just going to differentiate. So d by dCl of this bracket, it should be 0. Then what condition will get? That will give the minimum power required condition. Yes or no? Now we will perform this. Yes or no? Simple mathematics only. You need to perform this. What you will get? Take denominator. In denominator, what you will write? CL or 3 by 2 whole square. There should not be any confusion about it. And this is right side, it is 0. So make it 0. Take first denominator. So what is the denominator? CL to power 3 by 2. First denominator, then numerator derivative. So numerator derivative CD naught differentiation is what? 0 plus K. CL derivation is what? 2 CL. Yes or no? Then minus, take first numerator as the complete bracket, so it is nothing but CD naught plus KCL square. Okay. Into this denominator derivative. What is the denominator derivative? CL to power 3 by 2. What is the denominator derivative? It is 3 by 2 CL to power 3 by 2 minus 1. So it is nothing but 1 by 2. Okay, this denominator, because right side it is 0, so you can write this. What you can write? CL to power 3 by 2 outside the bracket. Okay, and this was up to here only. This big bracket, this was up to here only. Okay, so inside what you got? 2 KCL minus 3 by 2 CL to power 1 by 2, right? Sorry, first mistake. CL to power 1 by 2 in bracket CD naught plus KCL square, and right side it is 0, so denominator goes to 0 only. Check this again. I need to write, I think, this. What is the in bracket? 2 KCL minus CL 1 by 2 3 by 2 in bracket. It is nothing but CD naught plus. Just open this bracket. What you may get? 2 K Cl 3 by 2 Cl power 1, so 2 pi by 2. Yes or no? It's a 5 by 2. Please. This is some, it's like odd. 5 by 2 minus 3 by 2 CD naught Cl power 1 by 2 minus 3 by 2 K Cl 5 by 2 equal to 0. So what is the value here? Check. What is the value here? It is nothing but 2 KCl. Okay. This is what I can say. You just take this 2 first, relate it. So what you may get, uh, this will be what, 2 minus 3 by 2, 4 minus 3 by 2 means 1 by 2 KCl 5 by 2 minus 3 by 2 CD naught Cl for 1 by 2 equal to 0. So here it is nothing but, you can write this 1 by 2 KCl 5 by 2 is equal to 3 by 2 CD naught Cl for 1 by 2. This 2 also cancel out. So here it is KCl 5 by 2 is equal to, this is CD naught, right? 3 CD naught Cl 1 by 2. What is the next? KCl 5 by 2 3 CD naught Cl 1 by 2, I think. Yes. So what you may get? Check. It is 5 minus 2, 5 by 2 Cl, take this denominator, so 1 by 2, 5 by 2 minus 1 by 2, 5 minus 1 4, 4 by 2 2, KCl square is equal to 3 CD naught. So what is the Cl? Cl is nothing but 3 CD naught by K. This Cl is not normal Cl, this is Cl square actually. If you take Cl, then it will be root. This Cl is not Cl, normal Cl, this is Cl at minimum power required, hence it will be denoted by CLMP. What is that? 3 CD naught by K. Hope this one is clear to all. This is very important. Okay. So CLMP, not CLMP, CLMP. Okay. So here you have calculated. What you have calculated? Let me write this. Lip coefficient at minimum power required. Okay, then you can say CLMP 3 CD naught by K. Then you can write drag coefficient at minimum power required CDMP CD naught plus KCl square. What is the KCl square? KCl square you got here. See, this KCl square is nothing but 3 CD naught Okay, force it not. Very important. Very important. Okay, point one, point two. Now we'll calculate point three. What is that? Velocity at minimum power required. What is VMP? Same you can write 2W rho S CLMP. What is the CLMP? Okay. Then aerodynamic efficiency at minimum power required. So you can say L by D. At minimum power, what is L by D? CLMP by CDMP. What is the CLMP? 3 CD naught by K. What is the CDMP? It is 4 CD naught. Here check this one. No? Keep this value. So we got here done. This is related to power required. Next session, we'll see the further analysis of it. Okay, thank you all. So here we have seen that minimum power required condition. Okay, so what is the final conclusion for the minimum power required? So the condition for power required to be minimum is basically ACL square is equal to 3 CD naught, or CD naught is equal to 1 upon 3 KCL square. What is the KCD naught? KCD naught is nothing but parasite drag 1 upon 3 times of induced drag. So basically KCL square also already I explained. KCL square is nothing but CDL. So induced drag, these are the coefficient, but yes, you can write in terms of the drag also. So both are same. I mean, you can write parasite drag coefficient, you can say induced drag coefficient, you can say, or the same thing you can say parasite drag 1 by 3 times of induction. So this is very important. They are asking in exam. Okay. So always remember this formulation. All right. Is drag or drag coefficient meaning will be same. Okay. If drag parasite drag is equal to 1 by 3 times of induced drag, then obviously parasite drag coefficient also it will be 1 by 3 of induced drag coefficient. All right. Now we need to see here the one more analysis for the required to the minimum power required. What it is? Suppose we are interested to calculate power required at other speed. Okay. Required at other speed. So generally minimum power required you will achieve at minimum velocity. Velocity at minimum power required you will get. But if you want to calculate power required at some other speed, and that speed it is given like the velocity is what n times I'm considering to the, if, let me write here, if the speed is n times of minimum power required speed, that means this is the general speed and it is n times of the minimum power required speed. Yes or no? So now we have v is equal to n times of vmp, or what is the n? N is nothing but v upon vmp. All right. Now at this speed, suppose we want to calculate the power required. Okay. Then what will be the formulation for it? It's very important. Now we can take the analysis. What is that? We know that L is equal to W is equal to half rho V square S into CL. All right. As we are considering weight is the constant quantity, yes or no? So what you will get? You will get V square CL is equal to constant, because rest all the parameters will be constant here. Yes or no? Rest all the parameters will be constant here. So we take that two conditions, one at velocity at minimum power required and one is the normal speed. So because this product will be constant, then we can write v square CL is equal to, instead of this v, what we can write? We can write n times of vmp square, instead of CL, what we can write? CL, which is at minimum power required. Agree? So now this is the formulation. Okay. Now here we can get the value of CL. If we are interested to calculate, we can calculate what will be the value of CL. So what will be the value of CL? CL is nothing but CLMP, okay, divided by it is nothing but uh, you can say here it is nothing but, then correct here, actually this value will be, wait, let me, what I said, this part is, instead of v you are writing n times vmp, and this is as usual CL, and this equal to what will have vmp square into CL. Okay, because two condition we are taking. So you, this one is what it is, actually v is equal to, you have written n times vmp and whole square into CL, and this is nothing but vmp square CLMP. Okay. So now what you will do, you can calculate the value of n square vmp square into CL, and here you can write CLMP vmp square. What will be the value of CL? CL is nothing but CLMP divided by n square. This is very powerful formula actually. Okay, sometimes it is required to calculate lift coefficient at some given speed. So we'll solve the problem, you will understand it's very simple. And here you should not confuse, because what we have v square CL, so I can extend this part and I can write v square CL is equal to, I can write VMP square into CL. So instead of VMP, V square CL is equal to V square MP CLMP, means this product will always be constant. So V square CL you can write, instead of V you can write in terms of VMP CL as usual, and this part is what as usual here, and instead of V here we have written n times VMP. Alright, so hope it is very clear to all, there should not be any confusion. Okay, now so CL you have calculated. Similarly you can calculate CD also. What is the drag polar? It is nothing but CD is equal to CD naught plus KCL square. So for minimum power required, what you got? KCL square. Check here. Just now you have KCL square is equal to 3 CD naught. This is the one condition as I told you. You can replace this value. It is nothing but 3 CD naught. Yes or no? So what you can write, CD is equal to CD naught plus K, and KCL square is equal to 3 CD naught also you can write. Okay, then finally what you will get, 4 CD naught, and then again CD naught you have to replace in terms of CLMP, then you will get. Otherwise do one thing, you write K, and instead of CL you can, here because directly you have calculated here CL, so you can write CLMP n square. I mean, if you replace this value also, then you will get that CD in terms of the CD naught. It will be 4 CD naught. Otherwise, if you want to calculate in terms of n, then you replace CL value. Okay, and this is the KCL square, so make it CL square. Now, what you will have, CD is equal to, check what this value is. This is nothing but CD plus, what you may get, CD naught plus, here you will get KCLMP square divided by n to power 4. Yes or no? Now here you can write what is the KCLMP square, because KCL square is equal to 3 CD naught, that is correct. But if you check, this CL is nothing but KCLMP. Now you replace it. Okay, so it is CD naught plus, instead of KCLMP square it is nothing but 3 CD naught divided by n to power 4. So this one is very clear here. What you will get? You will get CD is equal to CD naught plus CD naught n to power 4. Here you can write CD naught 1 plus 3 upon n to power 4. Okay. So this is the value of CD. As I told you, this is very powerful formula also. Okay, directly you can calculate CD at some another speed. The condition you should know only was that what is the n? N is nothing but, only here only I told you, it is N is nothing but V upon VMP. What is the N here? Some other speed V will be given to you, VMP will be known, minimum power required speed. Okay, So this is the value of CD as I told you. Similarly, you can calculate L by D ratio also, but here I am going to calculate directly power because our heading is what the power required at other speed. Okay, so what will be the ratio of power required? So the ratio of power required to the minimum power required, it is nothing but P upon P min. Yes or no? What you can write? General, it is drag into velocity. It is the minimum power, hence it is dmp. Vmp. There should not be any confusion. Yes or no? What we can write is drag is nothing but W into this one. Already I told you how to substitute this. Okay. Already I explained, so no need to explain again why we are writing this in this format and how we can write. It is already explained here. Check previous lecture, you may get it. Okay. So P upon P min. What we will get? Take separately. W cancel out. Weight is what cancel out. So what you will get? You will get CD upon CDMP. Then you will get CLMP by CL you get VMP you get. Check what is the CD upon CDMP here. CD upon CDMP. Okay. So this is CD is equal to CD naught 1 plus 3 upon n to power 4. Okay. But this is what CD. What is the CD upon CDMP if I say? So CD MP is what? 4 times of CD naught. Yes or no? So if I will write how you will get this, it's very simple here. CD is what? CD naught plus KCL square, and this CD will not be normal, so this is the CDMP. CD naught plus KCL square, CD naught as it is. What is the KCL square here? Check. KCL square here for minimum power required. KCL square is nothing but 3 CD naught. You can write here. Directly you can write what you may get 4 times CD naught. So there should not be confusion like how it comes. It's very simple only. So CD upon CDMP. So it is 4 CD naught, na? So CD naught will cancel out, or one more step you can write CD. What is the value of CD? CD naught in bracket 1 plus 3. 1 plus 3 and power 4 divided by what is the 4 CD naught? 4 CD naught. Okay. Into CLMP by CL. What is the CLMP by CL? Check CLMP by CL. What is the CLMP by CLC here? CLMP by CL, it is n square. Check by this bracket. CL is equal to CLMP by n square. So what is CLMP by CL? It is n square. So CLMP by CL, it is n square. What is V upon VMP? It is n. Yes or no? There should not be any confusion. So here you may have P upon P min. What is that? CD naught cancel out here. See, this CD naught will be cancel out here. So you will have 1 upon 4 naught 3 into power 4 n cube, or 1 upon 4, you take this n cube, what we may have P upon Yes or no? This is very powerful. All right. So similarly, you can calculate L by D upon L by D minimum power. This is also you can calculate. You can calculate D upon DMP. This thing you can do by your own also if you want. So similarly here this is what it is, nothing but aerodynamic efficiency divided by, just like what I have done for the power required, same thing you can do this also. Okay, in next class will tell you, like you can do by your own also, not then I will solve it. Fine, thank you.